Hey everyone, in this video I want to explore the blob point-in-time restore capabilities. As the name suggests, the ability to take the state of my blob storage to any previous point in time, giving me a continuous backup solution. As always, if this is useful, a like and subscribe is appreciated. Now, before I talk about this idea of going back to a previous point in time, I did want to stress this is very different from replication and that kind of durability of the data. We always talk about, well, with a storage account, remember we deploy a storage account to a specific region. So for example, we'll say region 1. Now we have choices for the replication of the data in that storage account. If we consider many regions today are made up of these idea of multiple availability zones. They have independent power, cooling, communications. Now by default, if I don't change anything, I can say LRS. So if I say LRS, remember there are 3 copies of the data. So there's always 3 copies of the data. And so with LRS, I can really think about those 3 copies are spread over different nodes, disk, racks, but they're in the same data center. So if I think about that protects me from a failure of a disk, of a node, of a rack. If the entire data center had a problem, well, I have an issue. Then we can think about ZRS, zone redundant storage. Here, there's still 3 copies of my data, but those 3 copies are spread over the 3 availability zones. So now in addition to protection from a disk or a node or a rack failure, I also have protection from a data center failure. And then we always talk about the idea that, well, there are these region pairings. So that paired region 2, well, I can actually turn on this option of GRS. So with GRS, there's once again those 3 copies, but then asynchronously, it's copying that data to the paired region where there's another 3 copies of the data. And there is GZRS, where these 3 are actually over the availability zones, which are then asynchronously copies. So this is fantastic when I think about the durability of the data. Hey, I can survive a node, a disk, a rack, a data center, maybe even a regional failure. It gives me 0 protection from the idea of a data corruption, a logical data, something happening to the data. If something bad happens to the data, no matter which scenario I have here, if some change is made, well, that change replicates to all of the copies. So replication gives me protection from different types of failure scenarios. It does not give me protection from these logical corruption. That could be accidental. I run some commands and I accidentally delete a bunch of stuff, or I accidentally update a whole bunch of data. It could be malicious. Someone deliberately comes in and encrypts all my data. Well, any of those actions would just replicate out. So the solution, if there's a logical corruption, which means it's replicated to all of the copies, well, I basically want to go backwards in time. I want to be able to have previous points in time I can go back to. And that's what we're going to talk about in this video. So we're going to focus on block blobs. So when I think about, well, okay, well, what is a block blob? Well, if I think about the name, block blob, binary large object, a block blob is made up of blocks. I can have up to 50,000 blocks make up a particular block blob. So I can think about all these different blocks that I put. They each have IDs, and then I do a commit, an actual put of the block blob. So these particular blocks, for example, hey, these blocks make up my file. Just say 1.txt. So that's what a block blob is. It's made up of blocks. Those blocks can actually be really, really big. I think it's up to 256 megabytes today, but in preview, I think it's 5,000 megabytes, which means if I said 100 megabytes per block, now these can be variable sizes. within the blob. They don't all have to be the same size, but I can have up to a 4.75 tebibyte single blob. So these things can be huge. So okay, we have this blob made up to 50,000. So I put blocks with my various data in, then I do a put block list operation to actually commit and create my actual blob. Fantastic. So I've got all these different sizes. If I want to change it, what actually happens is, well, I would do a new put block of, hey, this new block I want. So I'm going to put this new version. And essentially I say, okay, well, I'm now going to do a put. I'm still going to use this block, but now I'm using that block instead, which is now my 1.txt. So that's how I can modify it. Now, technically, yes, I could just re-put all of the blocks. But as we're going to see, that could be super inefficient to replace all the blocks if they haven't actually changed. I can insert blocks. I could remove blocks. It's all about that operation where I put the list of blocks that are going to make up my blob. So that's the basis of what that blob is. It's made up of blocks. And to update the blob, I can just put new blocks and then do a commit to say which blocks I want to be part of my blob. And I can use ones that were already there as part of the existing file. I can insert, I can remove, I can replace. Okay, so let's think about, I want to be able to go back to previous points in time. That's my goal of this solution. So Azure Storage now has a point-in-time restore capability. And it's actually made up of 3 distinct features that we now have for Blob. The first one is versioning. So I can go and turn on versioning. Now, really exactly what we just saw happen here, I can think what versioning is going to do is ordinarily, if I made that update, well, this block is no longer referenced. It would just go away. It's lost. What versioning does is when I do that write operation that's committing a new version of the blob, what was current becomes kind of a previous version, and it keeps it. So now I could think about, well, it's still the same file, but in this example right here, this is no longer really 1.txt, it's a version of 1.txt. So this becomes maybe v1, and now the purple line actually now is the current version, or maybe you could say like a v2, is what we now have. If I made another change, well, actually now I'm going to change this block down here to create another version. Well, now maybe it's, okay, so it's this block, existing this block, and that block. Well, now they make a v3. So it's all about the versioning tracks and doesn't get rid of the old blocks. So I could always go back and say, hey, v2, well, it didn't delete the blocks that are no longer referenced. So I can always go back and make that version current. It doesn't delete these blocks until I say, hey, I don't want that version anymore. So versioning is all about the idea that if I make a write operation to the blob, it creates a new version. It maintains the old versions. So at any time, I could actually go back and make it current. And I can see this. So if we jump over to the portal quickly, let's go and look at our various configurations for this. So I'm in my storage account, and I want to go and look at data protection. Now what you're going to see is I'm going to have some things grayed out, but this is really what's happening behind the scenes, because I'm really using Azure Backup to operationally manage the state of my protection. You can see I've got this, hey, enable point-in-time restore that's grayed out. And then the things I want to talk about is, well, hey, look, this enable versioning for blobs. It's enabled and I can't turn it off. So this enable versioning for blobs is doing that functionality I just talked about. And I can see it in action. if I was to go and look at my containers, and I'll go and look at my images, for example, and I'll pick a new one that I just uploaded. So here's my image. If I look at versions, there aren't any. There were no previous versions, so I've never made a change. I created this, I've never changed it. If I look at a different file, once again, I've got my current version, and notice even the current one has a version ID. It's not version 1, 2, 3, 4, but I'm not going to write this on a board. But I can go and look at versions. And hey, look, I have previous versions now. Every time I've made a commit, a change to that blob, it's now keeping what the previous versions were. And if I wanted to, I could, hey, look, I could download it. I could make it the current version. I can go and look at all the properties of that particular version. So all of these are now just kept. So if we think about what this means, I can now go back in time. I can go and say, hey, there was a logical corruption. Now remember, if there was a logical corruption, that's a write to the blob. That's the only way it could do it. So that logical corruption would be a new version. What was there before the corruption would now, in this case, be the v3. Well, I can now go and make v3 the current version. So it gives me that ability to roll back in time. Now, this is great. What is it actually costing me behind the scenes? So think about what it has to do. Let's take the example of maybe I've removed a block, either because I've just completely deleted it from what is my blob, or I've replaced it. It now has to keep that block around because it's going to need it to go back to a version that uses that particular block. So what it's going to cost me is whatever the rate of change is, whatever the delta is, because it can't delete these now. It has to keep these around. So the additional cost is, in this case, these blocks, because they've actually been replaced. But to be able to go back to version 1, well, I have to have that block and that block. To go to version 2, oh yeah, well, okay, yeah, I need this block. So it has to keep the older blocks around. So what does it cost me? Well, it depends on the size of the blocks. If this was a huge 200 megabyte block, well, there's an extra 200 megabytes of data that I'm having to pay for. It's the same cost as active data. If it's a very small block, hey, it's not costing me very much. But that's what this is going to cost me in terms of using the versions. It doesn't have to duplicate all of it, but it has to keep the blocks that are replaced, which means I want to be efficient with how I use the blobs. If I'm changing data, whatever my application is doing, don't be lazy. If I have 100 blocks in the blob, I don't want to every time just re-upload the 100 blocks. Because even if it's the same content, it's going to be 100 new blocks. You'll have to maintain the 100 old blocks. So it's going to get pretty expensive. So I want to be efficient in how my application uses this works if it is changing the blobs. So it only puts the new block with the new data in and then references the existing blocks. So that's going to be the most optimal method. If I have blocks that are constantly changing really rapidly, this may not be the best solution. Maybe for those edge cases, put them in a different storage account without versioning. So just realize if I had something constantly changing, well, it's just going to have constant new versions. And there is also a performance impact when I try to enumerate this if I start to get beyond a certain point. I think they talk about beyond 1,000 versions, it's going to start to impact my performance. Now, there is not a native versioning checkbox to say, hey, only keep the last 28 days. Or only keep the last 10 versions. 10 versions wouldn't work very well because the whole point is I want to be able to go back to point in time. But what I can absolutely do with this is add lifecycle management. That's just a native feature of storage accounts. And that's what I've got on my environment right here. And this is super easy to do because I actually had a whole bunch of versions. For example, this file, Ollie and Eddie Cereal Eating, had 6, 7 versions, and that doesn't have any. Why doesn't it have any? Well, if we go and actually look at our lifecycle management, it has specific functionality for versions. So I created a new rule, and my rule targets blobs, and it's targeting versions. And then all I'm doing is, now I did 90 days. If a version is created more than 90 days ago, delete it. That's it. That's how simple it was for me. I picked 90 because I wanted to keep some versions even beyond my point in time restore goals, which I think I've got as 14 days. I just picked 90 days. But this is how you can keep this tidy. So I'm not just infinitely paying for loads of different versions I actually don't even care or want. Go and create a lifecycle management rule. Super easy to do. Make sure you don't make it shorter than my point in time goals. If I want to go back 14 days, don't start deleting them if they're newer than 14 days, obviously. But lifecycle management will help clear those up and keep me to a certain number of versions. That's going to optimize my cost. So I'm only keeping the versions I more likely care about that I want to be able to go back to. Like, do I really want to be able to go back to a version that's 90 days old? Probably not that useful to me. If there's been a logical corruption I don't notice for 90 days, well, I'm probably not doing my job very well. Also, performance. If I do have a fairly high rate of change, hey, it's going to keep me within a certain decent number. So versioning, great capability. Hey, use the lifecycle management. Be careful with how I interact with it. So that's step one, versioning. So versioning is going to let me have all of the previous versions of it. And again, I add lifecycle management to keep it within a manageable window. But if I want to be able to go back to a certain point in time, how do I know, well, which was the right version for a particular point in time? So the next feature we add to this, so hey, we're doing versioning, then we're going to add change feed. And exactly as the name suggests, and this is not really super interesting, it creates a transaction log. So when I turn on change feed, so we'll actually go and look at the data protection. And again, you're going to see in my environment, it's grayed out because I'm doing this as point in time restore. This is a mandatory feature. What it's doing behind the scenes is creating that transaction log. So what it's actually using is the Apache Avro format. And I can see it. It creates this folder, $blob change feed. It has an index, but it arranges the actual logs based on the date, day, and then I'll see the Avro files. So it's just maintaining a change feed, a transaction log of the changes that happen. And so with that change log, when I say, hey, I want to go back to 7 days ago at 10:05, it can rewind back and work out, well, which versions were the current ones. And this obviously includes metadata changes as well. Those will all get captured in here, so I can rewind and go back to that point in time. Now, once again, the basic point in time doesn't trim this change feed. But this time, something you can do is you can tell it, actually only keep a certain number of days, which is what I have got configured. So it will enable it, but instead of keeping all logs, I don't want to keep that much. Again, they're small files, but they are files. They're costing me money. I can actually say, hey, delete it after a certain number of days. Once again, do not pick a number of days less than what I'm trying to keep in terms of be able to rewind to point in time. So my goal, we're going to talk about, is 14 days. So I've picked 24. I'm giving it a bit of room. So I'm going to automatically get any change logs over 24 days deleted. So again, I'm using this to be able to rewind, to be able to go back in time. But then I've added that keep end days to just keep it a bit tidy. I don't need infinite amounts of transaction logs. I don't care. Now, you might be using that change feed for something else as well. Okay, maybe you do want to keep it for longer, but if you don't, then obviously you can go and clean this up. So what we've got right now is fantastic. I can go back to any point in time within the versions I have and the change feed log I have, what if someone deletes the file? So next feature we have is soft delete. So now what will happen is I can configure a retention from 1 to 365 days. If it's deleted, that deletion is really a new version. The undeleted data is kept. It gets marked as deleted, but all of the blocks are kept, and I can undelete it. If I have versionings, I just promote the non-deleted version back to the current version, and the file is back again. So this gives me that ability to now, hey, if the accident was I deleted a bunch of stuff, I can undelete it. I can bring it back. Once again, what's it costing me? It's active data. Instead of these blocks being deleted, they're kept for the duration, this n number of days. So I say this. So I'm going to carry on paying for those blocks of data for that number of days. So that's the cost to me. It can't delete them. And once again, we see this as the option here. Soft delete for blobs. Now notice what it has done is the sum of all these features powers this point-in-time restore option, which I've got turned on. It will automatically turn on soft delete for n plus 5. So n is the number of days I want point-in-time restore for. It adds 5 to that. So it makes it 19 to give me a nice window on that. So it turns on that soft delete capability. So now if you delete things, so I want to look to the images again, and I'll pick this file and I'll delete it. Yep, so it's gone. But notice I can, hey, show deleted blobs. Oh, look, there it is. I can select it. Because I got versionings, there's this undelete button, but it's telling me, hey, look, to undelete it, make a previous version the current version. So this is the deleted. I'll go to versions, and then I'll make, this was the most recent. I can see the dates in the version ID. So, okay, I'm going to make this version right here current. And it says, okay, completed that, has been successfully updated. Okay, let's close that down. Turn off show deleted, and it's back. It's back, and I still have all the versions. So now I can undelete things for whatever that retention time period is. And then really the sum part of this story is I could do all these bits separately. But the cool part now is all of these are basically grouped together and leveraged by point in time restore. So I go and configure point in time restore to be 14 days. It goes and turns on versioning. It goes and turns on the change feed. It turns on soft delete for my time 14 plus 5, so 19 days. I'm now protected. And what this adds is instead of me having to manually go to versions or manually do whatever, it treats it as a whole. And I can actually say, hey, I want to maybe revert the whole thing back to a certain point in time. So what this adds is now, if I just go and look at all my different containers, so I'll go back a level, all of this, I have this restore containers option. And I can either restore all of them, or I just want to select certain ones, maybe just images and maybe image write and source. Then I say restore selected, and even then I can be specific about what I want restored. So notice it's showing me a little picture of this is what we're going to restore. So anything starting with images, i.e. the container name, or image write and source to images-0, it's just a way to get the complete range of the content. But I could trim that down. I could be more specific. Well, actually, I only want images starting with blob A, maybe. It's showing me those examples, through to blob Z, if there's certain naming. So I've got some certain naming scheme. I can be specific about what I want to revert back to. and I've got this roll back to option. And what it's going to show me in this calendar is the number of days that I have configured to keep. So today is the 8th of June. I have it configured for 14 days, so I can pick any time within the 14-day window. Those are the days available to me. So I can go and pick a certain day, and then within that day, I can pick any time I want. It's continuous protection. Because of that change log, it doesn't actually care. So it gives me this fantastic ability now to have continuous protection, and I can go back to any time I want. There's a gap. So this is great, fantastic feature. The gap is if I deleted the container, if I deleted the storage account. So point-in-time restore protects me from deleting blobs within the container. Doesn't protect me if I deleted the container itself. It doesn't protect me if I deleted the storage account. So in addition to point-in-time restore, there's also the ability, and we want to add this, is the ability to add container soft delete. And exactly as the name suggests, I can now undelete the entire container. I can't undelete specific things in the container, but obviously I can do that because of these features, but this lets me bring back a deleted container, kind of back from the dead. So if I go to here, and if I went and looked again at my data protection, we can see I can also optionally turn on soft delete for containers. Now I've just got mine set to 7. I should probably really do that to 14. But there I can set, again, what do I want this to be? It's 7 by default. It can be up to 365 days. It can be as low as 1. So that will restore the complete container versions, everything. So that gives me protection from someone deleting a container. The other option is obviously deleting the storage account itself. And that's when we really just go in the old faithful locking. So what I can do is I could add a lock. So I can add a lock to the storage account, which would protect me from actually deleting the storage account. And so that really is the final piece of our puzzle. So point-in-time restore protects and gives me the ability to rewind the blobs. Container soft delete, hey, if someone deletes the entire container, and then a lock. I can go and configure all of those things myself. I can go in, do that. Or these parts here, I can manage with Azure Backup. So Azure Backup has support for Blob. It is an operational support, i.e., it is not taking the data and copying it to a recovery services vault. What it's doing is it gives me that central place to do the policy, and then I can assign that to multiple storage accounts, and it will go and configure point-in-time restore. It will go and add a lock for me. So it lets me en masse go and configure this idea of protection for my storage accounts, which is what you're seeing in my environment. That's why in my environment, if you go and look, that lock exists. And notice it's an Azure Backup protection lock. I can't delete it. You can see it's auto-created by Azure Backup. Azure Backup also is the one that did the data protection. That's why it's all grayed out. You can see, hey, I've enabled operational backup with Azure Backup. It's telling me the vault that it's doing for and the policy. It's why all of the features are grayed out, because they're all being managed by Azure Backup. So if I was to jump over to Backup Center, and then I change it from data source type from VMs to blobs, you can see that over here. So I'll make that change. Notice I have one instance protected, configured. I could create new policies. I already have a policy. So if I look at this, I've got my blob 14 days. 14 days sounds familiar. hey, retained for 14 days, which is why I have those values. And then I essentially assigned that to this particular storage account. So protection has been configured. So that's what Backup Center is doing for me for Blob. It is not copying the data to a recovery services vault. It's in-place protection. But it's giving me that ability to go back to any previous point in time within the window I configure through versioning. Change feed lets me work out which versions would have been at a certain point in time. Hey, if it's deleted, well, the soft delete lets me undelete things. It's locking the storage account, so I can't just go and delete the entire storage account. And then I could also add the container soft delete. So that's the sum of the features. The real key thing to bear in mind beyond what Azure Backup does is I would definitely think about, if you do have pretty changeable workloads, create that little lifecycle management to go and trim the older versions away, or it may start to affect performance and I'm just paying for blocks I don't even care about anymore. And you can go and set the number of days I want to keep for the change feed. Again, be careful with both of those. Don't have those values lower than the point in time place I want to be able to go back to. You're going to break it. But that's it. So it's actually a very simple set of things to do, but just realize the implications of cost. Hey, it has to keep those other blocks. But that's really the only cost. There's not another thing I have to pay for any of this. I just have to pay for the additional data it has to keep. And it is Delta. It's only the changed blocks that it has to additionally keep. Make sure your app is efficient. It's not recopying everything every single time, because even if the content was the same, if I was to upload all 4 blocks every time, these are all replaced. It's not checking, is it the same content? So I'd be having a massive amount of extra data and a huge waste of money. So just be efficient with how you use them. If the blobs are super small, if it's like a little image, probably not a big deal at all. But if they are bigger, yes, I want to be very efficient with what I do there. So that was it. I hope this helped explain what exactly the whole point in time restore and those capabilities are doing. As always, till next video, take care.